like a different thing today, because usually I was working on like a Node, bit of React kind of application. But today I want to do something different because I've recently was looking more into like blockchain technology, how that works, and the idea of today's stream, or yeah, is to kind of build some simple smart contract and at the end deploy. Maybe probably not in this session, but in one of the future ones, I'm gonna be deploying it to the Ethereum test network, Ringkabi. So we're not gonna do live deploys because that costs money, but the same principle should work in there as well. I don't have tons of experience doing this. I've went through some course recently and it was quite good. So I figured it would be fun to just kind of try it out and see how far we get. I'm doing this as a part of like rebuilding my website, and I want to have a section there which gonna be like a blockchain section, and you can kind of purchase this kind of virtual NFT because that's the hype, right? But as the owner of the NFT, you will get an option to change a text on that web page. So in the end, that web page will actually talk to the Ethereum backend. Like I think it's called DApp, as distributed application. That it talks directly to the Ethereum blockchain, and it's using it as a kind of database. So with the owner being able to change the state of the Ethereum blockchain, that should then be shown on the website. So the smart contract will be really simple. It's gonna be sort of NFT so that people can buy it and sell it. Well, no, you can't really sell it. You can just buy it, and then there will be another call which will change the text which is stored in the contract as well. So first we're gonna like make directory here. So this is already like React project, so have a bunch of stuff, but I didn't want to spin up to a separate repo because just wanted to keep it simple. But I'm gonna make a new folder here. Let's call it blockchain. And then inside here, we're gonna use Truffle, which is this is like a framework or set of tooling around smart contracts, which is really useful. To get it, you would just do install group Truffle, I guess. I think that should be it. Let's see. Yeah, it should probably fail because I already have it, or just say that I already have it. But yeah, so Truffle gives us several things. It sets up the environment kind of, so it gives you the basic structure of how you want to build your project. It also has some test functionality and migration functionality. Migration is in this context the ability to deploy the contracts anywhere really, and test is well test. Because these contracts, when you deploy them to the Ethereum or any blockchain, I guess, they are there forever and you can't change them. That's the whole purpose of the blockchain. So you want to have a good test coverage so that it kind of works. Sorry, this is taking much longer than I expected, but it's fine. Yeah, so one more thing about the contract that we're going to be building is, although I'm saying it's NFT, I mean by that it's like a token that anybody can really buy. But it's not going to be, because there are some standards in Ethereum blockchain already, and if you implement those standards, you get some added bonuses. Like for example, if you implement the NFT standard, you get probably ability to trade them on those marketplaces, while this one won't work that way. So yeah, I would need like sudo npm install global truffle, right? But because I didn't have it, it failed to install it to that path, which is protected. But it's the correct thing. So I already have it, but if you would need it, that's the way you install truffle. And then you can just do truffle init. So that gave us few folders. There's a contracts where our smart contract will go. Migrations, which is the deployment steps that I was talking about. We can look at that later. And then tests, where the tests go. And then there's a truffle config. So I'm gonna switch to VS Code for now. So there's this blockchain. So as I said before, this is, you can ignore everything else, which is not in this blockchain folder. Yeah, I now realize this might be a little bit confusing. Sorry about that. Well, so then we have the truffle config, which is a config. The important part, we will get to it, I guess. But the networks, yeah, let's just look at it when we get there. So contracts, there's one that is already pre-created for us, which is this migrations contract. And basically, from my understanding, this keeps track of your deployments. And then if you deploy the next one, it's just gonna help you do that. And then there is migrations, which is, so notice that this is .sol. So this is this is Solidity source file. And in migration, we have JavaScript file here. So this is JavaScript code that you would use to deploy it to somewhere. And then tests, there are two options. You can write tests either in JavaScript or Solidity. I'm gonna do JavaScript for this one because it seems easier. Right. So well, let's start. So I'm just gonna copy this just to get a template. I'm gonna call it Beaver Whisperer, and that's just because Whisperer. It's because my website is called Beaver Codes. Yeah, everything's so slow. My website is called Beaver Codes, so it's kind of like a joke that isn't that funny. Let's see, maybe we will need to do it in the terminal. Yeah, it worked in the end. Oh, whatever. So let's start from the beginning, I guess. Here on this line, we're specifying which version of a compiler do we need. Because the Solidity, how it works, it's a compiled language. So it's not like, so if you compare it to JavaScript, you can just run, node and whatever is your JavaScript file, like test.js, and the node will interpret the JavaScript on the fly kind of thing. Or same thing your browser really. But Solidity doesn't work this way. So Solidity, you first need to compile to another bytecode kind of thing, and then you deploy that to the Ethereum network. Which is also a reason why Solidity isn't the only language you can use to communicate with Ethereum blockchain, because there's a Python as well, I think, and then you just have a different compiler, and they both compile them to similar bytecode or the same bytecode, and you would deploy that bytecode. So here, though, we're specifying a version of compiler that we want to use because they, keep going forward. I think around now there's like a 0.84, but I guess to find out, I would just Google Solidity compiler. Yeah, right, the latest is 0.84, so let's use that, I guess. As I said at the beginning, I'm not super experienced, so kind of making up as I go. Beaver Whisper, we said. And yeah, so let's get rid of this. And yeah, so what we want to have is, there needs to be an owner, which is the current owner of the token itself. So that's the person that can change the text. We also need the text. So let's say string public, and then Beaver says. Cool. So this is the notation that you kind of create contracts in Solidity. It's very similar to classes in other languages. So instead of keyword class, you would use contract here, and then you specify the name of it, and then you start fields, and then we get to the functions of it. And there are some accessibility, how we call them, modifiers. So public is public, you can access it everywhere. There's a private as well. I think there's an internal as well. The difference is in how we call it, inheritance. So if you have a contract inheriting the other one, so I could have a contract. If I knew how to type, Beaver 2. Is that gonna work? No. Right, and so this is the is a keyword in Solidity, which is like a inheritance. So now I would get all the public fields from here to this contract as well. But if they would be private, then I wouldn't see them here. And I think there are more like, yeah, it's better to check when you need different things there. But basically public is what you want to expose, and private is what you want to have a keep secret. So not secret, but only accessible from within the code itself. So this is the text. Then we need owner. Now let's create creator, because I want to have an option to kind of decommission the contract. And also I'm thinking, just for fun, there would be a function to kind of claim all the funds from the sales of the token to the creator. So we still need to know who creator is, and then only creator can like call this function. And then we want last sale amount, because another idea I would have with this contract is that every time you buy the token, you need to pay more than the previous user, so that there's some fun in it, I guess. And yeah, well, so this is like a basic contract, right? And now I'm thinking I'm gonna do a little bit of testing at the same time, just to verify that I'm doing something correctly. So I'm gonna create a new test here and call it Beaver Whisper Jess. Man, my editor is really unhappy. Okay, I'll try to restart it. Let's see if that helps. Okay, and then I think you do contract here as well. I might need to look it up, but let's see. So it's using the chai library for assertions, and it has a bunch of other tools already built into it. So you basically just write your test here. Oh yeah, and I want you to forget. Here we get like some array of accounts that we can use to do some operations against that contract. Let's try that. And then I think you can just do it. And then this is the name of the test, right? Sorry, I didn't talk about that. But this is like a global name. And then you can, yeah, well, we can break it down, well, later maybe. And then you can say name of the test. So, I don't know, should initialize values. So in this test, we want to look into when we create the contract, when we deploy it, so that all the fields are correctly initialized, if that makes sense. So we can have a look at that. Yeah. And we will need to have it async, and that means we need to have this async, because it's when you're working with the blockchain, there's a lot of promise-based things that you like, asynchronous kind of calls that you want to do, and to avoid the waterfall with then in JavaScript, we can just use async and await on stuff. So I think we can do this. Contract new. Alright, and now we need the instance of our thing, of our contract. And I think, yeah, and you do it this way. So now I switch to the migration because I don't remember how to do this, but this is the way you get your contract object or class inside your other file. And this works both in the migrations and in the tests, so that's why I went to the migration to look into how that works. And here you just specify the name of the contract that you want to get, and this is just a local name for this class. Yeah, so if we say like this, no, I think we need to do it this way. Then we should have a contract. So let's see. Let's see if this works. So this is pretty cool. Let's go back to the bigger terminal. And then we should be able to just run truffle test, I think. Let's see what's gonna happen. Okay, so we got an error. This is very good. It says that we said that we want this version of Solidity compiler because I encountered this error before when I was just trying stuff. So I've already, I expected this to happen actually. But yeah, so it failed because we're using like version, I don't know, something 5.16, I don't know. But all that is specified in the config. So when we look in the truffle config, there are a bunch of stuff, right? Most of it, I have no idea what do. But one thing there is there's compiler. You're saying Solidity compiler version, and then we can specify our version. Yeah, so with that, should be able to compile this time. It might still fail, but hopefully we get a little bit further. No, it actually worked. Okay, and as you, let's go back here. let's go back to the yes, here. Oh yeah, let me do full screen. Maybe that helps. Yeah, all we really did this, which is this will deploy the contract on the test network, right? So this will deploy it and return an instance of that contract deployed, and then we just console log it, like print it out, so that we can see what's in that object. And when we look at it, there's a bunch of stuff in that object, which is really interesting. Like this is the bytecode, for instance. So this is the compiled version of that code that we've written. Right, so this is what gets deployed on the network. And yeah, but there's a bunch of other stuff, including, I think we should see somewhere our fields. Oh yeah, here we say, here are the methods. Yeah, that I should mention as well, I guess, is that whenever we have a public field like this, the compiler will automatically create public accessor methods for these fields. So it says function here, or methods, and those are the names of the fields we have. But if you call these methods, you get the value in those fields. Sorry. So let's try it out. Yeah. Okay. So I think to get like the message should be empty. But let's verify that as well. So Beaver says you would do contract and then, oops, Beaver says, which is this name, right? This is this name of this field, because we're trying to fetch this field, and we will verify what the value is in here. And we're going to do the same for all the fields. Yeah. Right, and you can do call here, I think. So let's just make sure that I'm not talking nonsense. I'm gonna be running it here so we can see what's happening, although that's a little bit smaller and harder to see. Oh yeah, I forgot one thing. Let's see what happens. Oh yeah, we don't have any assertions, so that's why. But as you can see, when we say console log here, we get back a promise. And that's because, as I mentioned, all of these calls are, well, synchronous. So we need this. We need a wait to get the actual value. Well, this has nothing in it probably, so that's why we don't see anything here. But let's just make sure that there's nothing in it. No. So there are a bunch of ways you can write these assertions. It's all the child library that we talked about. Let's open it somewhere. Here, API, maybe? Alright, here it is. So you can do should. There are 3 ways you can like use this library. and it's just about preference. And I'm using this middle one, which is expect something to be something. So that's that. So yeah, this worked, right? The beaver is empty. But maybe we don't want this to be empty actually. Maybe we want some initial value already. Like, damn it. As a dam, as a beaver, you get it? It's like funny. Yeah. But then our test should fail now because we expect damn it to be there. But it's probably not, it's definitely not there, right? Right, so it says that we expected damn it, but we got nothing. Okay, well, let's go back here. And let's add a constructor that will take beaver says string, and it's going to be public. So I put an underscore here, and that's because just to differentiate between the field, which you can do. Oh yeah, right, sorry. So in Solidity you do the type first, which is string, and then the name of the variable. I've done like a TypeScript kind of thing, which is not what you do here. And then, yeah, we can just initialize this thing like this. So we're saying whatever you send in a constructor, assign it to this field. What is it? Oh yeah, that's a good point. So you have two options where you want to store this string where it comes in as a constructor. There's a storage and memory. And the thing is that memory is cheap. Storage you pay for in a gas. So I have a question: any good resources for Web3? What do you mean by that? I mean, I'm kind of starting with this thing, but I'm gonna use. I'm just gonna like use the npm to install Web3 into my front-end code, and that should communicate with it. Or do you wanna? I bet I didn't answer your question really. Oh, okay, to learn Web3. Well, I don't know. I would just say play with it. That, well, depends what kind of learner are you. And myself, I'd just like to try stuff like this thing, although I'm clearly failing. You get to Google for stuff, right? I mean, I don't know. We're gonna do a little bit of Web3 later on. But yeah, cool. So let's init the other fields as well, or rather, so now our test might be passing, but it's probably not because we haven't really used it yet. Might actually fail because now we used to construct it without parameters, right? I think that should be, so visibility for constructor is ignored. Okay, that's fine. So this, what I'm reading here, is a result of our compilation. Just gave us some warnings because I guess constructor is always public or something. Yeah, okay, looks good. So when we look here we have a constructor. So we probably want to send something in here. Now when we have a field, like a parameter that you can send in, so you can do that. So I don't know, we could just send test. to see what happens. But what I'm expecting to happen is actually fail our test because we're comparing it to dammit and we're sending in test. Let's see. Yeah, exactly that's what happened. But let's, to avoid repetition, we can just do initial message, maybe. We can just say dammit then. And we can use it both here and in our expectation. For your question, how often do I stream? Not often. So I was streaming before, but it was mostly Node and React stuff, and I still do that. But what I usually do is just upload it to YouTube afterwards so that people can, because there's a limited archive on this thing on Twitch. I think there's a link in like my channel description or something where you can get to like a YouTube channel which has like 5 videos or something. So it's not crazy much. It's just, you know, I code for most of my days, but sometimes I get like a social vibe, so I come here. Yeah, so as we saw, this was starting to pass, which is amazing. It's exactly what we wanted. One thing, as we can already guess, is that we're going to be constructing this contract all the time. So we can move it up to some sort of thing that would happen before every, that would happen in before every test. So like a before each kind of thing. And then you just write a function that will run before every test. I'm just going to move this const outside of it so that we have access in it in our tests as well. And then we also, right, because we're doing this, the contract is scope to this scope, so we don't have access in it in this test to it, so we need something here as well. We can do this. Okay, now this is squiggly line here is telling us that we're doing wait, but this is not async code, so we just fix that. Yeah, it should work probably still. Oh yeah, link to the videos. Yeah, sure. Let me see. No. Yeah, here we go. Okay, back to this. So this still works, which is amazing. Well, let's check some other values that we have there. What else do we have there? Another thing is the owner and the creator. Those will be fun things. So you can do the same thing, I guess. But instead of checking for this field, we would check owner. And that's where the accounts that we got comes in. So what we wanna check is that the owner is one of the accounts that we got in here. So you can say account 0. But before we do that, let me just print out what's actually in the accounts. So let me know. What are we doing here? All right. So as we can see, it's just an array of bunch of addresses of different like wallets, I guess you would say. And it actually failed, right? Because what we're trying to do is check that the owner is equal to one of the accounts, but it is not. And why is it not? Is because there are two reasons right now. But one, we never initialize these values in the constructor or anywhere really. And in Solidity, all the variables or fields in this case gets like an initial value. An initial value for address is this thing that we see right here, like zeros everywhere. And yeah, as we saw before, for example, for string it was just empty string, and I guess for number it's just 0. Yeah, but we wanna initialize these fields. So owner, and what we can say is message sender. So message is a global variable that we get here in a contract or in a function rather, and it's linked to the transaction that came in that caused this to happen. So whenever you deploy a contract, there's a Ethereum transaction actually that deploys this contract, and it has a bunch of useful fields. One of which is sender, which is the person that initialized the transaction, that is paying for the gas kind of. Another useful field is message value, which is the amount that is being sent in the transaction. We don't need it here in the constructor, but we're gonna use it later when we're gonna start paying for stuff, like when we're gonna implement the actual like buy method of this NFT thingy, then we're gonna use that. Okay, well, so the message sender, the most importantly, creator is the message sender when we constructing this contract. Yes, the creator will be the sender, but because we don't really have any owner, we can initialize owner to the same thing as well. And then this last sale amount will just init to 0, which is what we want anyways, so we're kind of happy with that. Yeah, but that will still fail, and I'm gonna tell you why in a second, if it still fails. Okay, it didn't fail. Okay, well, I guess the thing I was trying to be clever and say is that we should specify from which account we're creating this thing. But I guess it falls back on account 0, which makes sense. So that's why it actually succeeded. But right now I just switched it to account 1 for fun, so that it's not the default one. And this time it should fail, hopefully. Because we're comparing the owner to the account 0 here, but we used account 1 to start it up. Right, so now it failed. To make it a little bit cleaner, let's create like a creator address accounts 1. So then when I look at this tomorrow or in a month, I know what I meant with account 1. Cool, and we can do the same for the creator here. Yeah, so the creator, we're just doing all the same thing. And then the last thing we wanted to check is, sorry, I'm doing too many things at the same time. So I ran the tests to verify that they both are good. But now I'm adding one more thing, which is the amounts. So last sale amount, boom. And now it comes a little bit tricky thing, maybe. Let's see. Because amounts, when we get these big numbers, right, it failed. And it failed because we got this BN 0, but we expected 0. So 0 here is a regular JavaScript number, but bn here is not a regular JavaScript number, because what the Solidity is using here is uint256, and I don't know about this, but I would guess that that's bigger than what JavaScript numbers are, or yeah, maybe. So those are different things, right? You have an object that has a value of zeros, but then you have a number that is 0. So there are a few things you can do with this. I think, if I don't remember correctly, I have no... You can do something like bn. Okay, let's Google it, because I don't remember. Big number. Yeah, utils, that sounds around right. Okay, so I think this should create a big number for us. Yeah, so we send in either a string or a number, and we get back instance of this big number. And I guess if we would be interested in what big number is, we can read more here. But it's, I guess, just a bigger number. Okay, did I copy this? Yes. So let's see if this works. And yeah, this probably won't work again. And the reason it's not a function. What? This init? Okay, that I didn't expect. So let's see. There was an option to send string, so let's see if that's the thing. Or maybe it doesn't like the equal doesn't like the thing. Maybe if we do this. Yeah, but I guess that's what coding is for, yeah. Find something's broken, and then you need to Google and try to figure out what's wrong. Which is fun. No, this init is not a function. Okay, so we're calling something. Let's see. I don't want to go there. So let's Google some more. So let's say truffle test big number. How to use big numbers in truffle tests. Stack Overflow. Is equals. So what I want to know. Yeah, look at it. Well, they're trying to do. They're doing the same thing. But somehow it doesn't work for me. Or you can do toString. Or we can do that probably. Let's do toString then. Wait. Let's try if this works. And because now we're not using the big number at all, right? Which was the error we got. So this worked, which is good. I guess we can use that. Yeah, there shouldn't be any problem with that. Cool, this is good. Well, one thing I thought of when I was writing this is that if these fields are public, can we actually change them? And I don't know. Solidity, can you set public number, public fields? Because that would be a problematic thing, right? If anybody could just set them. Right, that's a good question. No, for public variable with global scope within a contract. Okay, so only getters are created, not setters, which is good. So then we are fine. Okay, well this is pretty cool. So let's create another function. There's a keyword function if you want to create a function. Let's call it buy. And let's make it public. And there's another keyword, payable, we want to do. So you need payable keyword if you want to be able to pay towards this contract. So so if you would have other function without this, I guess it would just fail. But we can try it actually. So let's try this. Yeah. Let's go back here. We're gonna write another test, which, well, actually, let's do a little bit to organize things. We can use describe here, which is like the try thing, I guess. And again, like a bunch of lambdas here, but so it just gives us a little bit like a prefix in this report in the end that we're gonna get to make it more cleaner what failed. So it's a should change owner. So whenever we buy a token, we want that to actually change owner of the token. Right. Sounds good. And then yeah, so we can do something like this, right? And we're gonna say, well, async again. And then we want to say buyer. Let's say, what was that? Accounts is a thing. Let's say the third one, bought it. And then we expect buyer to be this person. Well, this obviously is hopefully it's gonna fail because we haven't implemented anything here, nor have we implemented the code, the body of the buy method. But we can see. So as you can see now, we get this kind of like indentation, I guess, which is this describe thing sorted out this. And then it failed, right? Because the creator is still the owner. We haven't done anything. But it's nice. Let's do wait. And then how do we do that? Do we just call buy? Is that it? Yeah. And let's say from buyer. So we're like, normally you would send arguments to this function, but it doesn't have any arguments. What truffle does is that it lets you put one more argument, which is like an options of this way of calling this function, or yeah. And calling in functions in Ethereum, you can do two ways. You can either do transaction, or you can do a call. So we're doing call here, but the calls are they are limited. Like you can only read stuff. You cannot change any state, because what you do as a call, you don't ask to change the state. So you would just check your local node that you're looking at, like what's the value of that field. But if you're doing transaction, the whole mining thing comes into place, and it sends the transaction to all the peers, and it just, it's a lot of work. So that's why you need to pay for it. And when we're saying pay for it, I mean, you would spend a thing called gas. You probably are aware if you're looking at this, but that's just like a way to evaluate difficulty of your code, is that they measure it in gas, and then gas gets somehow translated to like small fractions of ether to do. Yeah. Okay, well, it looked like we actually called it, and it didn't fail. We didn't change the guy, but it's okay because we haven't implemented that part. I guess what we want to do here is we're going to change the owner to the message sender if somebody buys this. We're going to add more logic there, but just for now. Let's see if this worked. Yeah, perfect. So this worked. So this guy, the buyer, account 3, bought this token, and now he's the owner under that contract. So that's really good. Yeah. Well, another thing we want to do is that well, let's write another test for this. We will come back here and fix this one, which will start failing. We talked about that we would like every buyer to pay more than the previous one. So let's do that. Let's verify that happens. Should fail if caller pays less. Or the same amount. So let's put 2 test cases here as previous owner. Okay. So let's do this. We don't need that. It can be the same owner, doesn't matter really. So let's do this. So now we're doing value here, and we're saying when that guy sent the transaction, he also included 10 ways. The Ethereum way. And I was hoping to get some like, oh, here, this table. Right, so way is the smallest unit in Ethereum network kind of thing. You have ether, and that's 1 and so many zeros of ways. So that's the lowest denominator, if that's a word. And that's what you would get in that value. Because as you have noticed, maybe, we're not dealing with any floating point numbers. Everything is just one big integer, like a whole number. So we need to be dealing with the lowest denominator, and then take it from there. So yeah, so this guy would, let's say, would send 10, and then if somebody would try to send, well, let's say buyer 1, buyer 2, or the first buyer, and failed buyer, because the second buyer will actually fail to buy the thing. Because he will just offer 10, which is the same amount, and then he will offer even less, 5. And then we're gonna have a first buyer here. And then we're gonna verify one more thing, that after all that, the owner is still the first buyer, which is the person who actually correctly bought it. So let's see what happens now. Again, we haven't implemented the code yet, so it's fully expected this to fail. Well, hello, Vlasim Bonatsos. Alright, so it did fail. Why did it fail? Yeah, I think, well, it failed because we got some petition transaction revert. And I guess that's, I never tried it, so that's possibly what the error is. Because we haven't marked this function to be payable. So it's not possible to pay to this. If we do mark it as a payable, we might get a different error. Let's see. Oh yeah, perfect. So we get error. Oh, one neat thing here, you can just, find this and do control click, and it points you where it fails. So it failed because these people actually managed to buy the thing, right? Even if they pay less or the same amount, or same amount or less. So yeah, let's see how we can make it so that it doesn't do it. In Solidity we have keyword, I guess, function require, which basically you put a condition here, and if that condition is not true, then it's going to stop its execution, roll back everything it done, and then yeah, basically like a rollback in database words. So we can say if the message value is high, well, message value needs to be higher than the last sale amount. Yeah, right. Solidity is fun. So as I said in the beginning, I don't know what I'm doing. I'm kind of trying to learn myself how to do this while failing publicly. So that's fun. And the second parameter here is like an error message that we can return to somebody calling this so that they know why it failed. We can say something like, some more, serious for people to know why it failed. And let's see if this fails. Oh yeah, one thing. It's probably not going to fail again. No, yeah, that's perfect. Yeah, so it failed again. And that's one more, because we this thing, right? We're comparing to last sale amount, but that's here it's 0 and it never ever changes, so it's always 0. So the only way this could fail actually is if we would send 0 in it, which we actually have done, right? So yeah, right, that's really interesting. So now we can see that for the buy, going back to our tests, you have this buy block here. Both number 1 and number 2 fails. So should change owner also is failing now. And it's failing for exactly that reason, because we added the require now. Because if we haven't put any value here, we're sending 0 way or 0 ether there. And then if we look into our require here, we're saying the value needs to be higher than 0, right? It's not higher or equal, but it's higher. So then that fails for that person. So we're just gonna fix the first test by adding some amount here. Let's see. Yes. So as we can see, the first test now succeeded, but the second one is still failing. And that's because what I said before, we're not updating these amounts. So another thing we're gonna do is just update it to last sale value. I have a back thing where it hurts. I don't know. Well, but yeah, it failed, right? Which is amazing. Well, it's not that great because the test is failing, but we got this message. The exception was reverted with this message, which is what we put there. So I'm just gonna copy it, and then when we gonna go back to our test, right? So it turns out if they fail, they throw exceptions. So that's why we're gonna do try catch block, and we're gonna say expect. I think it's the reason in this thing. Let's see, or to equal. No, the same one for the other one. This is the worst formatting ever. We can format document. Perfect. There's one more issue with this test, assuming that it's actually passing, and that yes, it's passing. So we kind of check the owner, so we know these things didn't succeed. But if they would succeed and didn't change the owner for some reason, and we wouldn't go to this catch clause, we wouldn't get an error, right? It would just pass, which is wrong. So what we can do is accept fail, which is kind of unconditional fail of a test. Let's just double check that that's really true. That if we put it here, it should fail no matter what. And if that's true, then we're just gonna put it here. Yes, it did fail. Perfect. So what's gonna happen here is that this line is gonna get executed, but it will throw exception. So it will not run any code after it, but rather skip right here to the catch exception block. But if it would pass, it would just call this line, which will just break the test and stop executing. So that's good. Now we have a nice test for this. Yeah, let's see. Did we missed anything? So we bought a thing, the owner gets changed, last sale amount gets updated. This looks really good, I think. Well, let's do another thing, which is why would you actually buy this thing? Is to change the text, right? That's why you want to buy this. So let's have a function. What does the beaver says? Oh, I guess it's say if there is does. Oh, but I have beaver says. Okay, let's do that. Let's just do set, which is kind of boring, but okay. And then we're gonna say text, whatever. That's not important. And we're gonna make it public. And this is red y. Yes, again, memory versus which I just know that memory is cheap. So if I can get away with memory, then that's good. So that's good. Let's see if we can write a test for this as well. So I'm going to copy this whole describe block. It's because I'm kind of lazy by nature. And we can get rid of these tests. And set beaver says. First thing, it should only work for the owner, right? So it's, let's say, fail for non-owner. So let's say buyer buys it. That's cool. And then, yes. And then somebody else tries to set what Beaver says to, I don't know, Fluff Fluff. And we're gonna send this from some other account, like 5. We haven't used 5 yet, I think. Yes. Perfect. And as before, we kind of expect this to throw exception, because this guy isn't the owner of the NFT or whatever. Yep. And let's steal this part. And some message. You are not my owner. Sounds good, I think. As before, expect to fail here. This makes sense, I think. Now again, we haven't implemented anything, so we're kind of doing test-driven development while at the same time not knowing what we're doing, which is the best combination ever. But hopefully expected undefined to equal you are not my owner. Well, it still throws some exception. Oh yeah, I think it throws this exception actually. Let's test it. Because that's what's happening. This actually passed and then it went here and failed, and then that throws exception as well, which goes here. Which is kind of tricky, but that's why we checking the reason why it failed. No, well, never mind. I'm pretty sure that's it. Let's console log the exception here. But maybe the text you provide here doesn't go to the reason, and that's why it didn't compare nothing to this. Yeah, right, so this is the exception from this line, console log, which says, you know, expect fail. So that's why we are here, which is great. So everything works. So we're gonna just use require again, and if the message, oh, sorry about that. I might need to take that. Well, we're running for 1 hour anyways, so I think I'm gonna leave it here and then come back later in weird time. But as I mentioned, I will again upload it to YouTube, so even though you will not catch me here and for some reason you would still like to watch me fail here, there's the YouTube channel. I'm gonna post it to chat again, but I think it's somewhere in description of something. At some point I put it there. Yeah, but that's it. Well, thank you so much for watching me fail. And yeah, I will try to do this again when I get a chance. It was fun, and I actually managed to do quite a lot. I thought it's gonna be harder. Okay, see you next time. Bye bye.